Right, so I think we're on air. This Hangout is live. Switch on Q&A. I'm just waiting for that to open. And I want to screen share. There we go. Okay, I'll just switch to this screen. So no, I can't resize that. Never mind, it's all right. We're going to be all right. Okay, fine. So, computer science. 1 minute before I start teaching. Speaking to the people on YouTube. People of YouTube. Right, so I simply do not understand this. How can it be Monday, the day of the test, there were so many people in class, and today there's no one? What do you want? Valdo. It's not Valdo. Let's try it. It's your name, Valdo. No, it's not. Okay, don't mind. Right, so I'm going to start. Firstly, let's talk about the test. Was it okay? You all survived? That good. Okay. Okay, so who found it really hard? Was it really hard? Don't be sorry. Okay. So everybody's happy. No issues. Tuesdays are my research day. I haven't touched those tests. They're still lying on my couch in a big heap. But I will start marking them today, and they should be done by our next class. Giving you the marks is somewhat tricky because I will have to negotiate Sun-Learn, and that seems to be the most difficult thing for me to do. So I'll see if I can somehow squeeze the marks onto Sun-Learn because I want you to have your marks. I'm not going to return the answer sheets to you, answer papers. If you want them, if you want to look at your answer paper, please come and talk to me. I'll show it to you. I keep them. 5 years. I'll put the test itself and the memo also on the web as well, so you can have a look at those if you're unsure. Perhaps you're just not bothered about the test. But perhaps you are bothered about the test because you still have to write it. So, do any of you still have to write the test? One person. I know there are many. Well, we'll probably have to write it next week, but we still have to agree a time. So please come and give me your name after class. Okay? If you don't, I will forget about you. I'm not going to remind you that you have to write the test. But please come and give me your name. If you're on YouTube and you still have to write the test, please come. Send me an email. Or come to me. That's even better. Right, so there will be a retest. Not a retest. It's not a retest. If you've written the test once, your chance is passed. But if you were ill or you had some kind of other kind of emergency, then there is a makeup test. There is not a makeup practical test. So on Thursday, you're writing essentially Monday's test again, but just the programming part. Not the same questions, but the same kind of idea. I'll ask you TUT-like questions, and you have to implement them. And then you have to submit that on Sun-Learn as well, and then you leave. And the test will be, excuse me 1 second, the test will be in Naga H and Naga H and Naga D. Because we need separation. So we'll sort that out. Yes?
Die ou tutoriale wat ons gedoen het, mag ek by wat sê, of mag ons nie? Is dit 'n oorloop? Ja.
Dit is basies onmoontlik vir my om jou te stop om na die ou tutoriale te kyk. So dit is makliker vir hom te sê, go for it. As ek weet baie slegte nuus is, want dit beteken dat die toets moeilik genoeg moet wees sodat die ou tutorial jou nie sal help nie, maar maklik genoeg sodat as jy al die ou tutoriale gedoen het, dat jy die toetsvrae ook sal kan doen. Maar verstaan julle wat ek bedoel? So gaan ergens in die spot wees waar jy maar na die ou tutoriale kan kyk, dit gaan jou nie help nie. En dit te laat gaan wees vir jou om te swat vir die toets in die toets. Verstaan jy wat ek sê? Okay, excellent, uitstekend. Any other questions? But so you're allowed to look at all tutorials, and by extension, you're allowed to look at your textbook. You can bring that along. What you can't do is use the internet to go outside university, like Google, for a solution, or to send SMSs to your mother to ask her how to do stuff, talk to your friends how to do stuff. Apparently, there's new technology that's for sale on the internet, and they advertise it specifically for this purpose. In fact, there are ads on YouTube you can watch where they sell glasses like these. My glasses are thick and black because I sat on my last pair, so now they're big, so I can see them when I take them off. I don't have bad eyesight, I just can't see. So they've got thick glasses like this, and I'll show the people at home. I can show you my thick glasses like this. There we go. You know my glasses, they're glasses. And they have a little camera in them, so that whatever you look at is picked up by the camera and transmitted over the internet to some friend or some assistant who knows. Your friends probably haven't passed this course either, but there's some assistant somewhere who's a big expert, and they watch the little screen to see what you are seeing, how you're looking at the questions and all that. And then the glasses also have a little microphone in the earpiece, in the ear. It works with Bluetooth or Wi-Fi, not Wi-Fi probably, but Bluetooth. And these people can actually feed you back answers. Which is why I'm afraid you'll all be blindfolded during the test. It's the only thing we can, it's the only way we can ensure that we're not using this kind of technology. Right, okay. So let's see. Is anybody asking, so Fahik is supposed to be here with someone from Google today, but they haven't shown up. So I'm guessing that they may still be coming. I also don't have a little assistant who will tell me if there are questions on the internet. So from time to time, I'll just have a peek here. But my audience don't seem to have questions. I think I should be able to see them. I'll check again in a few minutes. In fact, I don't want to neglect them. I have a little gadget that I used in previous teaching. Just so everyone can see, this is my egg timer, okay? And I'm not lying to you. I will now set it to 10 minutes. Okay, so we'll just put it down there. So in 10 minutes, I'll check the questions again. But I wanted to show you really there's something else on the internet, which is our schedule. So what are we doing? What are we supposed to do today? We were supposed to finish searching and performance last week and talk about this thing called dynamic programming, which sounds exciting. And to me, it is exciting because it's a kind of special kind of programming technique. Oh, that's so soothing, that little ticking. But I think it's driving the people on the internet insane. Yeah. We'll still hear it, but they won't. It's a special kind of technique used in programming for solving certain kinds of problems. So it's not as if you're dynamically programming on rollerblades and that kind of stuff, but it's really exciting stuff and we must do it, but we'll get back to it later on. And Monday we were supposed to start searching and sorting, sorting and searching rather, but we'll do that today. We'll start talking about sorting and searching today. Why do we want to talk about sorting and searching? It's one of the most common higher level operations that we do in computer science. When we write software, a lot of the time what we're really doing is searching through a database or a list or an array for an element. And at least until now, the ways we've had of doing that was simply start at index 0, and step through the array, and if you find what you're looking for, if A of I is equal to my target, then I stop and I found it. And if I reach the end and I haven't found it, then it's not there. But there are much, I mean, that's terrible, because if you look frequently looking for something that's not there, you have to look at n elements every single time. And the amazing thing is you can do much better than that. You don't have to look at all the elements to tell that a certain element is not there. Or do you? I so frequently make mistakes. It's hard to be sure. But let's find an assistant. Everybody's looking down. Oh no. Oh no. What's your name again? Yes? Dion. Okay. Is that true, do you think? I have an array with a lot of integers. I'm looking for number 10. Do I have to, I mean, I want to know, is 10 in the array? Do I have to look at all the elements in the array to know that 10 is not there? This will be most accurate. How can you not? I mean, what if I don't look at the first element or one of the elements, and that's the element that contains the 10? Dion?
Nou, as jy die eerste een check en jy check alle ander eenes, dan moet jy aanneem dat die een is as jy wil.
Maar dalk is hy glad daar nie.
Ja,
dan moet ek eers een check om te weet wat daar is of nie. So that's not helping. Okay. Now think about this simple, really nice solution. What if we, I mean, you're going to say I'm cheating, but what if we keep the minimum of all the elements in the array in a special variable? So one time we scan the elements and we find that the smallest element in the array is 17. And before I check if an element, a new element like 10, is in the array, I first compare 10 and 17. The smallest element in the array is 17. 10 is less than 17, so it cannot possibly be in the array. You see, Dion? I've just saved all that time. I didn't have to look at all the elements. I could know somehow that it wasn't there. And similarly, I can store the biggest element in the array as well. So if the biggest is 28 and I'm looking for 100, I can tell immediately that it cannot possibly be in the array because the elements in the array are between 17 and 100. So that's a kind of cheating way, and I mean, it only works if I'm looking for really small numbers or really large numbers. But there are other tricks we can use to search much faster through a database or an array or all that stuff. And one of the tricks we use is sorting. So if we sort the array, we have ways of searching it much, much faster. But another, sorting can stand on its own. Another application of sorting is producing a nice list of sorted student numbers. And you guys, I sort all of you every single day almost. I sort you either by your student number if I'm looking, if I only have the student number, I want to see if where someone is, or by your surnames because sometimes I only have your names and I want to check someone out, see what they're doing. So sorting a list is often really, really useful. And we use sorting for advanced stuff as well. Now, I showed you the picture of Donald Knuth. So we're doing searching and sorting. But before we do that, I showed you a picture of Donald Knuth. Well, this is disappointing. Why is this always so shiny? Okay, that doesn't look right. Okay. I think this might help. Aha! Okay, I'm just lowering the exposure. You should still be able to see that this is the title. This is his big encyclopedia. He started writing this in the 60s, or maybe the 70s. And oops, my phone is switched off. I just don't want a lot of beeping. There we go. I can hear the ticking of the egg. Soon it will be time. Okay, I don't want to look before then. So Donald Knuth, Donald E. Knuth, there his name is at the bottom. There we go. He's a really famous computer scientist. He invented many algorithms that we all use. He invented the software that made this book. So this books used to be typeset, which meant that you write your book on paper or you type it out in a typewriter, and someone somewhere has a big case, a wooden case, like a small bookshelf. And then if you wrote it was a dark and stormy night, their job was to find the I for it and put the I in the bookcase. It, so T is next, T, then a space character, put that space in there, then a W, A, S, space, a dark and stormy night, and so forth. And each of these letters was a little piece of metal. You don't believe me, but I will show you on the internet, so-called internet, typesetting metal letters. Aha! On eBay. Okay. It used to be little blocks like that. And they had a big case like this, a big box, where all the W's were in one little box, and all the A's and all the S's. And then they used to pick from that and make up. Oh, that's not. Let's see if we can make it bigger. The internet's. Oh no. Okay, hang on. The internet just wants to switch on. There we go. Internet is switched on. And then they used to put all the letters of the sentence you were writing in your book. They put in a line like that, and they'd cast that. They have a special machine that makes a metal sheet with that page's letters on it, and then that sheet is used to roll in the ink and press onto pages physically. And that's how books were printed. It's amazing. In fact, that's how books were printed since the 16th century when they invented printing. Well, unless you're Chinese, which of course your culture invented it much earlier. We respect your culture. Please do not destroy us economically. But this is how books were printed for a very long time, until Donald Knuth came along and said, I want my books to be handled digitally. I wanted to be able to write my books on a computer. Oh, questions. Let's see. I am here. Well, good. For the practice, oh, this is not good. Can I make it bigger? Hang on, guys. I'm making it bigger. Select. Selecting question. I can't see a thing. This isn't helping. Hang on. No, I don't. I want to open it. I just want to make it really much bigger. Okay, so I'm going to have to do something radical. Here we go. Here we go. Can you change the screen? I think I already have. I'm really sorry, but let's just make sure that screen share is set onto desktop. Okay, I hope that's right. I hope you didn't miss almost everything. There are people here, and they're really happy. And what happened to for the question? For the practice test, will we have something like a JUnit test to check our work? No, I'm not going to give you a JUnit test, but I will be using JUnit test to mark your questions. JUnit testing is not the only way of testing your program. And what does +5 mean? Oh, 5 people want to know that. Okay, good. So can I do something with I have to delete? No, I don't want to delete it. Okay, fine. But I think this is better, and we can live like this. Obviously, the screen needs to be much bigger. But yeah, let's get back to what we really want to talk about. I think that's it. So, Donald Knuth wrote this book, and before he started, he wrote the first version of this book in the 70s or the 60s perhaps. Then he spent the whole 70s, most of the 70s and the early 80s, developing a system called TAG, with which you could type books like a word processor, and they would be printed on paper like this. And so this whole book is really not generated by a computer, but it was done on a computer. Think how impossibly difficult it is to typeset stuff like this neatly. Yes.
Is it equal content like that?
So this book is made with tag. On top of that, you can write any kind of macros, and there's lots of different macros sets that people use, and one of them is LaTeX, made by Leslie Lamport, which is why it's called, I call it LaTeX, but I guess Lamport LaTeX. It should be called. And I use LaTeX every single day to typeset your test, for example, or to write my own research papers, or to make notes for students, and so forth. So what I really wanted, why I brought this book along, and why I'm wasting so much time on it, is that this is volume 3 of Searching of Computer Programming. And I'm just resetting the timer. Soon I will check for more questions. This is volume 3. And this whole book is all about searching and sorting. Sorting and searching. I don't know why I keep mixing it up. But it's quite a thick book. I mean, you could probably tell that, well, you can see. It starts on page 1, clearly. Okay. No, I was worried that it might be continued from the last volume. And it ends on page 775. Well, that's the index. But it's a thick book, just all about searching and sorting. And this isn't even updated for newer techniques developed since he wrote this. He published this, which was in second edition, 98. So in the last 16 years, things have changed, and new techniques have developed. And yeah, as he says here, research on searching and sorting continues to grow at a phenomenal rate. So there's a lot for us to learn about sorting and searching. We're not going to learn all of it. Definitely not. Perhaps not even in our lifetimes. You may die without knowing everything about sorting and searching that you want to know or can know. But that's fine, because we only want to know the basics for now, and we can carry on with that. So let's start with what the book says. So there are many of these techniques we can use, and they each have a name. So there's searching, and then there are many kinds of searching. And there's sorting, and there are many kinds of sorting. And the very first one we encounter is called sequential search. So this means we start with the first element of the array, and in this case we're going to stick to arrays because they're easy to understand them. We start with the first element of the array, and we simply look at each of the indices until we reach the end. We find what we are looking for, we can stop. Otherwise, we have to say that the element is not there. So let's just have a little look at this code. It's a static public method. That makes a lot of sense. And it's going to return an int. It's called search. It takes string key, which is the target that we are looking for. And it takes string array A, which is our array that we are going to search in. It returns an integer, which is odd. I mean, why doesn't it return a string? Well, what string would it return? It would be stupid to return key, because we already know what key is. The client that's calling this routine is not interested in key, really. He wants to know, is key somewhere in the array A? And more than that, he probably wants to know exactly where it is. And that's why this integer that we return is the index in the array where key was found. Or, as it says here at the top, -1. So if we find it, we're going to call it a search hit. If we miss, if the array is not there, if we can't find it, we call it a search miss. Yes. Sorry, okay, what's your name? It starts with B.
Ryan.
Does it end Ryan?
Yeah.
Oh, okay. Yes.
How does that compilation method work? Because obviously.
Well, we get to that in a second. In a small second. Okay. I'm not going to tell you how it works, but I'll tell you what it'll. Well, who knows? Anyways, let's start with that, Brian, since you're online now. What's going on here? Explain to us what you are thinking, the computer is thinking. It's storing the length of A in end. Why is it doing that?
question, I'm not sure.
That is the right answer. This is obviously a little typo in the book. On the slides, of course. Because he's initializing an integer variable n, and he's never ever using it again. We can't see it outside the search method. It's a private, it's a local variable inside search, and it won't be visible from outside. And if we don't use it in search, we're never going to use it. So where would you suggest the author does use it, Brian?
You don't need it because you can just use, you can directly reference it.
Yes. Probably in this case you are right, but in many cases we're not dealing with an array, but with a more dynamic structure like a list or other advanced containers we'll learn about. And in those cases, every time you make this comparison in the for loop, you have to say, is I less than the size of my container? The size of my container may be something that's growing or shrinking all the time. So every single time you make this comparison, it's going to call a.length. Okay, a.length is a field, but often for containers it's a function. We're going to call it a function for every single comparison in this for loop, and that's wasteful. So often people do this. It's a little pattern that you need to learn. You don't have to follow it, but some people love doing it, and sometimes it makes things clearer. Find the size of the array first, and we store that in a local variable like n. And then in our for loop, this person should have said int I equals 0, while I is less than n, I++. So instead of calculating the size of a every single iteration, we only do it once and store it in a local variable, then we use it in the future. Okay, and then inside the for loop, which, by the way, does not have braces, which I severely disapprove of. You should not be writing for loops without braces. You should not be writing if statements without braces. If you think, I am big and strong enough, Jaco is not the boss of me, he won't tell me, he won't be telling me what to do, then I shall simply tell you that in the last week, in the last 7 days, I received an email from one of my colleagues in computer science who says, I can't believe my code was broken. I don't know how this could have happened, but I forgot to write the braces in my if statement. And then later on, I added something to it, and that's why the code broke. So this happens to everybody. We're just human. We forget that I didn't put braces around this in the body of this for loop. So if I add anything to it, I have to add the braces then later on. At the moment, it only contains one if statement. It looks like it contains a return, but the return is inside the if, and the if is inside the for. But if you want to do anything else to this for statement, you will need braces. So add them there from the start. I mean, I can't even write an if or for statement without braces. I never, ever, ever do it. And I suggest you don't either. But it's your life. Okie dokie, right. So let's see the body. Inside the body it says, if element I of A, so A of I, dot compared to the key is 0, then return I. So obviously this test must mean if I found key in A. Brian, what's your question? Say again? How does compare to work? Oh, you're asking me what does compare to do in general? Just give me 1 second. I just want to fetch the text. Is that the textbook? So compare to is a great function. You should definitely know it and love it. Love it like a brother, really. Okay, so we just switch our screen to the textbook. Oh, this is beautiful. No, here we go. Class string. So here we go. Compare to. Oh, it doesn't tell us what it does. Oh, that's stupid. So now I have to go search in the book, and I'm too lazy. But you can do that. If you look in the index of the book, you'll find compare to, and it'll explain that it's a function that takes a string in this case, and it compares the instance to that string. If I am less than a string I'm comparing myself to, this function will return a negative number. Sometimes we can just say it will return -1. So for some kinds of objects, it'll return -1, 0, or +1. -1 means that whatever instance you sent a string to, let's say, that instance was less than t. I feel I'm confusing myself, so I'm going to write it down now. Yeah, I'll return your textbook soon. So let's write. Whoa. Excellent. So let's write it down. Today is the 27th of the 8th of 2014. It's page 1 of RW144. And I think that's invisible. So I'll just zoom out. Hang on. Oh, man. I mean, it's like you're sleeping and suddenly the alarm goes off. Let's make that a little brighter. I'm sorry, Internet. I didn't mean to disrespect you. Let's see. Questions. Is that last word latex or actually latex? So the word is spelled like this last, like latex, the substance that you all love so much, but it's pronounced latex because it's from the Greek word tech. Where's Alex? Anybody else Greek in the class? Technein, but it means method or technology, basically. So I pronounce it latex and tech, but it's spelled latex. Chapter 2.3 are not on the website yet. That's very true, and I will put them there almost immediately. So, I mean, I've answered that question. I just want to make sure we're not getting confused here. And I've answered that question. And I'll, can you change the screen? I did do that, yes. Can you change the screen? Jakub, could you perhaps repeat the questions that I asked in class, please? Yes, I shall do that, because I know how disturbing it is when you watch. So if you ask questions, try to speak up in class, but I will also repeat them. Okay, that's done, and that I don't have to answer, and that I don't have to answer either. And I'm really happy that so many people are watching this, and I'll set the egg timer, and now we can go back to our explanation of compared to. 10 minutes. 10 minutes is, no, yeah, it's left 20 minutes. So compared to, it's a really interesting function. You'll see it a lot because many objects have a function with exactly the same name. So for example, no, not for example, I'll first do string. I have a string S, and then I can call compare to. Let's say I have two strings, S and T. And they have some values. I don't know what they are, but they have some value. Now I want to compare S and T. For example, it may be two surnames, and I want to find out which one comes first in the telephone directory or in the index of a book or in my contact list. I want to compare S and T. So I say S dot compare to T. And this will return an integer. So that sends back an integer. And this integer will be one of three things. It will be negative. So that is negative. Oh, it looks a little too bright. I'll just tone it down a little. It will be negative, so less than 0, which means that S is less than T. S comes strictly before T. You know what I'm talking about. If you look in the dictionary, then aardvark comes before somebody. So comes before?
Zombie.
Zombie. Okay, excellent. I wasn't even going to go there. Yes?
Sorry, when you say S is some string is less than another string, what does that actually mean? Does it mean its length is less? Does it mean
it means the official name is called lexicographic ordering. Lexicographic ordering. And this is exactly the same as dictionary order. Brian, have you seen a dictionary? If you know dictionaries? You know what a dictionary is? Okay, you've seen them? Did you learn at school how to organize the words in dictionary order? How? What do you mean alphabetically? I mean, if I take two words, aardvark and art school, suppose actually two words I know, but let's pretend it's one school, one word. I mean, both start with an A, so are they now in alphabetical order?
It compares the entire string, or the entire word.
Oh, so it's not in alphabetical order because D comes, well, R comes before, hang on. V comes after C.
Yeah, but it will start from 0, and if
Yes.
0 comes before.
0 comes before.
If 0 the one string comes before 0 the other string, and it will continually run through the string like that until.
Yes. I mean, I sense that you know how it works, but it's really tricky to explain. I mean, how do you explain to someone exactly how dictionary order works? And that's part of computer science. We have to sometimes communicate algorithms to other people, and we want to be absolutely precise. So you've already tasted the bitter disappointment of not understanding someone else's explanation. You've surely been to a TUT where you thought, I don't have a clue of what this question means. And it's probably because I couldn't communicate what I want you to write. So dictionary ordering, we start with the first letter. Compare the first letter. If one of the words' first letters is less than the other word's first letter in the alphabet, so the word of one letter comes before the word of another letter in the alphabet, that first word comes first in dictionary ordering, and we stop. If it comes after this word of the letter of the second word in the alphabet, that second word comes first and we stop. And otherwise, they must be equal, like A and A, and we move on to the next letter. And if at any time we've reached the end of one of the words, then that word will go first in the dictionary ordering. So if I had to compare R, which I think is a word in the dictionary, which means what, Scrabble players? Yes, it's kind of Hawaiian volcano, if I remember correctly. Or Alcoholics Anonymous, thank you. Thank you for contributing from your own experience. Okay. No, AA is a great organization. I know people in AA and they are really helps them. Or it could be, of course, the AA, the Automobile Association, another great organization that really help people. I mean, and unlike the Alcoholics Anonymous, they even have trucks, which is always better, I feel, for any such organization. So what was I going to say? I was going to say that we compare the two A's, but they're equal. Second letter, we compare, but they're equal. Third letter, we've run out of the letters for one word, so that word that we've run out of will come first. So now I am so far behind what I really want to talk about that it's amazing, but this is part of comparing stuff and sorting them, so it's not all bad. And we will definitely come across lexicographic ordering in the future. Okay, so back to string comparison. If this compare to routine returns an integer that's less than 0, I know that S comes before T in the dictionary. If it's equal to 0, and I'm going to write mathematics here, we know that the two strings are absolutely identical. They contain exactly the same characters. And if it's more than 0, it means that S comes after T in the dictionary. You'll be really surprised and shocked, I think, to learn that you can do the same thing with integers. There is a special class in Java that is like string, but can store an integer. No, it is not your faithful little int that you've been using all this time. It's called BigI Integer. And I can put an integer into BigI Integer. Oh, sorry, almost had a syntax error. Okay, right. So there's something called BigI Integer, which is a class, an object, instance of an integer. Now, just like before with other objects, A, if I had int A, let's call it int A. If I tell Java that, it would find some memory for me somewhere, it would attach the name AA, and it would store 3 right in there. That's what int does. And we use it so much that it's got this special, it's a special case in the Java language. But integer A works very differently. Integer A works like this. It says, oh, Jaco wants an instance of the integer class, of the integer data type. So I'm going to have some memory somewhere where I'll store this, a pointer, a reference to this integer. And when I do this assignment, it actually says, oh, this must be an instance of integer. So find some space somewhere in memory, store the integer 3. And we don't know how much memory this takes. We've never seen the integer class before. Integer instance. And store a pointer to this class in A. I mean, this is amazing stuff. So we've been using with ints, we've been using ints, just small ints all the time, and everything's been going fine. But there's actually a way of making real objects, integers to be real objects, that you can send messages to. So I can send a message to this integer A. I can call one of its methods. I can perform an operation on it. I can ask it, A, compare yourself to B. Okay. It's like working in a restaurant. Hang on. There we go. Does each character get compared by ASCII values? Yes. Let's say for now that we are comparing the ASCII values of the characters in the string. It's a little more complicated than that because Java actually caters for not only the 256 characters we can manipulate with ASCII values, but 65,000 different characters to cater for all the alphabets of the world. It's called something called Unicode, wide characters, but for now we can just think of it as ASCII. Now, would you put all the class notes online? I shall. I promise. After this class, I'm having staff to you. But after that, I'll put all the slides online. Staff is really important for us because we discuss important matters. We discuss the students we think are having trouble. Honestly, we do. We care. We're caring people. Okay, right. Brian, who sits next to you? Simone. Whatever. And Sean, you've grown shorter. He's supposed to be in his dorm room, in his pajamas. We specified. No, I'm kidding. What's your name again? Balkan. What?
Balkan.
Balkan. Like the Balkan States.
Balkan.
Malcolm, with an N.
Yeah.
Yes, Malcolm. You're looking glum.
Sorry?
You're looking glum, with an N. Are you okay? Am I confusing you? I just want to make sure. Okay? Okay, fine. Okay, so I'm not confusing Malcolm. Let's reset the timer, and that'll also be bumped to stop. I'll set it to 8 minutes. 8 minutes, and I'll answer the question and stop. So we were talking about compare to an integer. I can ask this integer, compare yourself to B. And B is a pointer to another integer, BigI integer class, instance rather. And compare to will send back 3 values. It will send back some negative value. In fact, it will send back -1 to mean that A is an integer less than B. And it will send back equal to 0 if A is equal to B. And it will send back more than 0 if A is. And you might wonder, why do we want this? I mean, I could just directly compare the integers. Why do I even want to have a special class and have this method? And the truth is that sometimes I want to make a set of stuff. And I want to write an algorithm that will, for example, search through my set of stuff. But I don't want to specify what that stuff will be. So I just want a set of some things. And I can write this code without really knowing that I'm dealing with strings. I mean, what really is specific about strings, about this code that specifies strings? It's really only the string here and the string there. So if I can find a way to say, I want a key parameter that is something, I don't know exactly what. I want an array of those things, but I'm not going to tell you exactly which data type. This search method will work for all those data types, any data type, as long as that data type has this compare to method. If I can perform the compare to operation on the elements of this array and on key, I can use this code for anything. And in fact, that's part of the power of object orientation, because I can write that kind of code. On this slide, it's not yet there yet, but in the future, we'll look at how to write that. So let's just finish this off. I compare the ith element at AI. I compare that to key, and if it is exactly 0, then I know that I found the key in the array at position I, and I send back I, which is the place where I found it in the array. And now the client can use that I to, let's say, erase the element, or to tell the user that I found your record, or whatever it wants to do with I. And otherwise, if the whole for loop completes, and this if is never true, then I won't have returned anything. I will reach this part of the code, and I'll return a -1, which is a kind of signal that it's not an array. -1 cannot be a legal array index. All array indices start from 0. So that's sequential search. Whew. Right. Okay, so this is just an application of it. And what they did was they read a sorted list of strings from a whitelist file and print out all the strings from standard input that is not in the whitelist. So first it reads strings from a file, like they call it a whitelist, I would call it a dictionary. And then it starts reading strings from standard input. The user has to type them on the keyboard. And every time you type something that's not in the whitelist, it prints it out on the screen. Now this is a stupid program because it just prints out the strings as it finds them. But I can think of a much more important use. I can think that it could read a real dictionary, an English dictionary, from a file, and then instead of typing my dictionary on the keyboard, I'll just pipe my file that I'm writing, my big novel. It's about this. I can't say this. Okay, no. Let's just say it's a novel about something. I'll make the joke another time. I pipe this big novel using the redirection like that. I pipe my novel to the program, and so it's reading the words in my novel, and each one it's trying to find in the big dictionary that I've supplied with the program with. And if it doesn't find a word, it means that I've written a word in the novel that's not in the dictionary, and it's probably a typo. At the very least, it should alert me. So I would have rephrases if I had ever decided to use it as a tutorial problem, so that it would print here potential typo. Now in this case, it's using it with a lot of email addresses, and then if any email address you enter online is not, this is the test file, that's a real whitelist. If this file contains an email address that's not in the whitelist, it's printed because that's kind of an unallowed email address. The whitelist is a list of okay email addresses that's safe to send to. Okay. Let's see. How long will this take? Let's answer this little question, and we can stop. Probably have to stop this in a minute. A credit card company needs to whitelist 10 million customer account numbers, processing 10,000 transactions per second. Using sequential search, what kind of computer is needed? Our options are a toaster, cell phone, laptop, supercomputer, or Google server farm. Is a toaster a computer? Is there a computer in your toaster?
Well, there's a chip.
That's good enough for me. If there's a chip, it means it can execute instructions. It can probably store some values in memory. You have to have a really smart toaster that works like that. Most toasters don't. Okay. Let me just answer a question on the internet, and then I will. Can you integer.parseInt integer? Oh, you've seen the BigI Integer class, of course, because you've been using it for parseInt all this time. Can you integer.parseInt an integer variable to an int? No, there's no need, because parseInt takes a string. It takes a string and sends you back the int that's equal to that string. And there are other ways of taking an int and an integer and converting one to the other. Okay, so I'm going to stop there. Thank you very much for coming to class. Before you go, just let's hear what Ian asks. Important.
Does this integer class actually extend the class string?
No, it's not an extension of string. It's something totally different. And very importantly, if you have to write the makeup test, please come and see me or send me an email as soon as possible. You'll miss it if you don't. Thank you very much. Thank you, guys.